We have another example. Please take a look at the left side. We have the sum of two logarithms. The coefficients of the logarithms are ones, one and invisible one also over here. Next, you're supposed to look at the base of each log. Base 4 and base 4. We have the same base. That's why I can use the property for the logarithm of the product. The sum of two logarithms gives me the log of the product. That's why I'm going to rewrite the left side as logarithm base 4, and inside of the parentheses I'm going to have 6x minus 1 times 14 equals 2. I'm supposed to distribute this 14 into the parentheses and simply write logarithm base 4, and I have 6 times 14 is 84x minus 14 equals 2. Next, I'm supposed to convert the logarithmic form to the exponential and simply write 4 to the second power is equal 84x minus 14. Next, please keep in mind that 4 to the second power is equal 16. I have 16 and I have negative 14 on the right side. I have to move this 14 to the left side because I do not have x next to it, because I have to combine the like terms. I'm going to have positive 14 equals 84x. 16 plus 14 is equal, equals 84x. In order to find the value of x, we have to divide both sides equation by the coefficient of x by 84. 84 and 84 will cancel out, and I'm going to have 30 over 84. 30 and 84 we can reduce by 6. 30 divided by 6 is 5, and 84 divided by 6 is 14. So x is equal 5 over 14. X is positive. So let's check how it's going to work in our problem. The domain of this logarithm is already positive, so I don't care about this logarithm. I just care about the one with x. So I have 6 times 5 over 14. 6 times 5 over 14 minus 1. This has to be greater than 0. So I have 6 times 5 is equal 30 over 14 minus 1. 30 divided by 14 is equal 2 and 2 14ths minus 1, which is equal 2 and 1/7 minus 1, which is equal 1 and 1/7. So the domain for this logarithm is going to be positive number. That's why this is the solution to my problem.